Okay, so the water cycle, or the hydrologic cycle. Gotta love the water cycle. The water cycle. So we're going to basically be talking about what's in the air for the next couple minutes, and water is a big component of it. It's a cycle, can't really start anywhere, but I'm going to choose the oceans. There's water in the ocean, it evaporates. When it evaporates, it starts to condense. That's what produces the clouds. When too much gets condensed, you get precipitation. Now, it could precipitate over the water like it's showing, or it could precipitate over the land like it's showing. When it does that over the land, you have a couple things it can do. Right? It can just run off, right? You see the big arrow, run off, and down the land and into back to the ocean. It's like through the lake, streams, whatever, back to the ocean. It all is trying to get back to the ocean. Another thing it can do is it can go down into the ground here. Right? And as it goes into the ground, it's called infiltration, and it becomes groundwater. Okay? And again, it basically goes back to the ocean. So it all wants to go back to the ocean, so it can repeat the cycle. You have evaporation, precipitation, runoff or infiltration, back to the ocean, evaporation, precipitation, runoff or infiltration, back to the ocean, and you get the point, right? Alright, so what is in the air other than water? Well, the air is not just gas. Like when you talk about air, a lot of people just think, oh yeah, the gas that's around us. No, it's not just gas. It's gas, liquid, and solid. Right, we already kind of talked about the liquid being the water, and we'll get to the solid. Not pretty. Anyway, the air does change from place to place. You ever hear those annoying people that are like, but Arizona is such a nice place because it's dry air, and you're just like, no, really, just shush it, right? Well, they're right. I'm sorry, but they're right. There is a dry air versus a wet air. You live in Florida. Guess where? Guess which one you have. So it changes place to place. The amount of water will change. The amount of stuff in the air will change. The amount of different gases will change. It changes. Now, what's also interesting is a lot of people think, oh, it's oxygen, right? Air, oh, it's oxygen. Right? Well, no, it's actually mostly nitrogen. Okay, oxygen and nitrogen together is pretty much all of it. But nitrogen is the bigger component. Nitrogen is the 78%, whereas oxygen is only 25-ish%, right? So basically, nitrogen is 3/4 of the air, oxygen is the other quarter, give or take. Okay, and I do love this graph because it's like nitrogen, oxygen, and then the next biggest one, the green, everyone's like, oh, that's carbon dioxide. Nope, that's argon. And then the next biggest one, the purple there, yeah, everyone's like, okay, that's nope, that's water. And then the next biggest one, oh, that's carbon dioxide. Yeah, that's carbon dioxide. So carbon dioxide, we'll talk about it, but you can see they actually had to blow it up so that you could see it. Yeah, here's carbon dioxide. So you always hear about carbon dioxide reported in large numbers, in the hundreds usually, and the ppm. Now they usually either just say ppm real quick or brush over it, but it's ppm, it's not percentage. And what's ppm? Parts per million, right? So there's your big scary graph, right? And you can see it's definitely going up. Like nobody's going to say it's not. It's silly. There it is. It's going up. However, always look at the axes, right? And so the one axis is part per million, and it starts at like 300, and it goes to 400. So it's a really small amount, right? It doesn't start at 0 and go up, because if it did, you wouldn't see this trend, right? So they have to blow it up. And then the year, I know it's a few years out of date, but there you go. Now, why they don't say percentages? Because no one's attention will be spiked or sparked by the percentage. The percentage of carbon dioxide in the air is 0.04%. So they use part per million. Okay. Now, obviously, we all know carbon dioxide contributes to the heating of the Earth, right? Contributes to heating anywhere. Contributes to heating in Venus and blah, blah, blah. Anywhere there's carbon dioxide, it will contribute to heating. 60% of everything that gets output gets taken up by plants or water. Even though you're like, oh, well, we're cutting down our plants or we're outputting too much, it's still 60%. Humidity, right? Water in the air. It's called humidity, the amount of water vapor in the air. Now, this is fun because I always like to kind of freak people out a little bit. Oh, it's so humid. Well, really, only about 4% of our air is water. 4%. Right, so you're like, oh, wait a second, what about the whole, it's 90% humidity today? We'll get there. It's something different. The amount of water in the air is only between 0 at its lowest, I think it's actually 0.01, but who cares, 0, to 4. That's it. So Florida probably has like 4, 3.9, 3.8, something like that. And, those dry heat people, they're closer to the 0 end. And so, yes, there is a difference. Okay? But why is water why is this 4% so important? Because it does clouds and precipitation, right? That is the source of all the clouds and all the precipitation. All the different kinds of clouds, all the different kinds of precipitation is water, right? Or H2O. Okay, so remember I said things solid in the air, right? Yeah, they're called aerosols, kind of a tiny liquid and solid particles. That's an aerosol, okay? So when we talk aerosols in the air, there's things like sea salt. Like, I'm a fan of sea salt, right? I put it on stuff and I eat it. I like sea salt. And we're surrounded by water. So in my little puny brain, I'm going to say there's lots of sea salt in the air here, and so that's what's in the air, right? Soil is in the air. Okay, sometimes you just can't deny that soil happens to be in the air, right? There was just a storm, and right before that there was some really intense wind, and it blew all of the dirt that they're plowing behind my fence there. It blew all of that up, and so I could see the soil in the air. That was not fun. Smoke, right? Smoke's in the air all the time. Sometimes you can see them. Fireworks go off. You can see the smoke, right? Smoke. Pollen. Okay, we live in Florida. Enough said, right? Ash and dust. And it's always fun. You see the stream of light coming in and you can see the dust. It's gross, right? And you get to breathe that stuff in, right? But what's even more interesting is that there are microorganisms in the air that you breathe into your lungs. Right? So this is why you can't do yoga. Because they always ask you to do a deep breath. And so everyone's like, oh, and I'm just like, microorganisms, ash, dust, dirt, all just went into my lungs because you want me to take a deep breath. How about no? Kind of grosses you out if you just think about that. Just think about that every time you take a breath. Microorganisms, ash, dust, smoke, dirt, soil. So that's why in my little brain, I'm like, no, we live in Tampa. It's surrounded by water. I'm going with it's just sea salt. I just ignore everything else because icky, right? And the alternative is, well, don't breathe. Yeah. Don't try that. Okay? That won't work. You'll die. So it's like, okay, die or breathe in microorganisms. Again, I'm just sea salt, sea salt, sea salt, right? Now, why is this stuff good? Because this is the stuff that helps the clouds form. Why is this stuff good? Well, these help the colors of the sunset form. Right? So the more junk you have in the air, right, the prettier your sunset. So, I don't know, I watch Fox 13, I don't know if you guys do, but they usually give away a mug to the prettiest sunset. And you're going, no, we don't want pretty sunsets. That just means there's more stuff in the air. And my sister-in-law, she came down to Florida to visit us, and she's a big fan of Florida. She's a big fan of Florida. However, she's from, let's just go with Detroit. And so she comes down, she's, having a good time, and she does say, she's like, Florida's great, but they don't have the sunsets like we do. And I'm like, yeah, they don't have the stuff in the air like Detroit does. right? And we have cleaner air than Detroit. Gee, I wonder why. Anywho, and so I tried to tell her that, and she was just insisting that no, it's because Tampa is closer to the poles than Detroit, and so therefore the sunset. I'm like, yeah, you just think of that, because really, there's more junk in the air up there. All right, what else is in the air? Ozone. Ozone. I love ozone. Right. Now, kind of feel like I forget because I'm like, hey, I love ozone. I'm like, hey, they can't talk about carbon dioxide in percentage because there's not enough of it to be considered, high. However, with parts per million, they can be. So ozone, however, I love ozone. Why do I love ozone? Because it requires UV to form. That means when the sun blasts us with UV, which it does every day, all day, then it takes that UV and it traps it so it doesn't come down to me, right? Because UV loves my skin. And I tan a lovely shade of lobster. So I don't really like UV too much. So I'm like, yay, ozone! However, how much ozone do we actually have? Okay, carbon dioxide, 400 parts per million. Ozone, 0.3. That doesn't say 3, that says 0.3 parts per million. Really? Yeah, and it says here we're losing ozone everywhere. We're not anymore, by the way, we're gaining it. But we were losing ozone, and so we were, 0.3, really? Is that something to worry about? Yes. Because if you lose ozone, then skin cancer can happen to you. Your immune system gets reduced. Blindness, sickness, basically you die, right? So we need this ozone, only 0.3 ppm.